Sure, you can give exam in DSA. Yeah, you can give your GATE exam in that. Okay, guys, we are live. If there is anybody in the chat section, please let me know if I'm properly audible and visible to everybody. Okay, Natraj. So sorry, guys, it gets delayed because of some technical issue. Just let me know if I'm audible. Technical issue. Okay, so I think everything is fine. Yeah, I think now it's fine. So guys, yesterday I have shared this question with you and I told you that it is based on you have to use single linkage hierarchical clustering, right? In yesterday we have solved one question based on complete linkage hierarchical clustering, and I told you that if you need to find out distance here in complete linkage hierarchical clustering, how would you find out distance between D of AB, right? Distance between two clusters is basically minimum of dx. Sorry, here we take maximum. In complete linkage, we take the distance maximum of dxy, where x belongs to A and y belongs to B, right? This is your distance you would take in complete linkage hierarchical clustering. Now the question is that if I'll solve the same question based on single linkage hierarchical clustering, right? So let me know what is the distance here. So if I'll make you remember the distance, so basically the distance for single linkages, you have to find out distance between two clusters by taking minimum of dx comma y, where dxy is the distance between the points x and y, and a and b is the cluster, right, where x belongs to A and y belongs to B. Right, so this is a distance formula in single linkage hierarchical clustering. Now you have to form clusters for a dendrogram. So at the start, if I am working on agglomerative clustering, what we would do, we'll first take each point as a single cluster. So we have one cluster which has point A, another cluster which has point B, another cluster which has point C, another cluster which has point D, and the next cluster which has point E. Right, so I have 5 points each of our clusters, right? Now the question here is that if each of these are cluster, first I have to join any two clusters. So I'll see here what is a minimum distance. So I can see here that this is a minimum distance. So now I get another cluster, that means C and E gets combined. So I get 4 clusters, A, B, and I have C comma E and D. Right, so these are 4 clusters I'll get in the next step. Now next step is that I have to find out a distance matrix for these 4, right? So what would I do? I'll find out distance matrix for these clusters A, B, C comma E and D. Now you would say that same thing, ma'am, we have done in the last class, but the distance formula is different, right? We have done that same thing, but the distance formula is different because we were working on complete linkage. Here I am using single linkage. Now let me know, guys, what would be the distance. So distance with A with A is 0. Distance of A with B is 9. If I need to find out distance of A with C, how do I find out distance of? That means I need to find out distance between cluster A and cluster C comma E. How would you find out this distance? You would find out distance between A and C and distance between A and E. So the distance between A and C is 3 and distance between A and E is 11. So out of these two distances, you would take minimum distance because that is the definition of single linkage. So that means this distance is 3. So you would get the distance here 3. Right? That's how I find out distance between two clusters in single linkage hierarchical clustering. Right? Now the next thing is that distance between A and D. The distance between A and D is 6. Now distance between B and A is 9. Distance between B and B is 0. Now you need to find out distance between B and C. Can you guys tell me what is the distance of single linkage between point B and C, comma E? Let me know, guys, what would be the distance? What would I do? I have to find out distance between the cluster B and with the cluster C, comma E. So what would I do? I'll find out distance of B, comma C and distance of B, comma E. Right? What is the distance between B, comma C? That is 7. And distance of B, comma E, that is 10. So you would take minimum distance, so that would be 7. Right? So this distance is 7. Now distance with B with D, that is simple, that is 5. Similarly, distance, now you can write down 3, 7, and this is 6, 5. Distance of C with C is 0. Now you need to find out distance of C with D. Can I write down directly? Distance of D with C is 9. Distance of D with E is 8. So obviously, you would get the distance here 8. Right? So this is a distance metric. Now, can you guys tell me that which of the clusters gets combined now at this step? Just tell me, guys, which clusters gets combined here. So now if you would see, what is the minimum distance here? Minimum distance is this. So that means A gets combined with this cluster C, comma E. Right? So that means third set of clusters, you would get A, comma C, comma E, and you are left with B and D. Then again, you have to find out the distance metric between these three clusters. Then you would take the minimum distance and then combine them. Right? So let's do that again. Now I need to find out distance between ACE, BD. A, comma C, comma E, and B and D. ACE and B and D. I need to find out the distance. Distance of ACE with AC is 0. Can you guys tell me what is the distance of this cluster ACE with the cluster B? What would I do? I need to find out distance of the cluster A, comma C, comma E with the cluster B. Right? What would be the distance? I'll find out distance of A, comma B, distance of C, comma B, and distance of E, comma B. And whichever distance is minimum, I'll take that. So distance of A with B is 9, C with B is 7, and distance of E with B is 10. So I get this distance 7, so it would become 7. Okay, Prashant, like yesterday I have told the team to add that neural network lecture in the playlist, but if it's not done, I'll discuss with them again and make sure that it would get added today. So sorry for that. So sorry for the inconvenience, but yeah, we will make sure that it would get added. Now guys, tell me what is the distance between the cluster A, C, E and D? Distance between two clusters. So I am writing directly. Distance of A with D is 6. Distance of C with D is 9. And distance of E with D is 8. Whatever is minimum, 6 is minimum. So we get this distance. This is 0. This is 0. Distance of B with D is 5 and 5. Now you can see that whichever is minimum. So here minimum distance is 5. So now you can see that B and D gets combined. So we'll have A, comma C, comma E, and we have B, comma 2. Right? So we get these two clusters. Now the last step is I'll combine all the points to get one cluster. Both the clusters to get one cluster. Right? So this is my set of clusters. Like this is my procedure. But they asked me to draw a dendrogram. So you can draw a dendrogram somewhat like this. So if I'll draw a dendrogram here, let's say I'll write down A, B, and let me write down here D and C and E. Or let's say I'll take here A, C, E, B, D. I'm taking like this. Why I'm taking like this? So that I can draw proper dendrogram. Because C first gets combined, and then A gets combined with C. Then your B and D gets combined, and then later on, all these 5 points gets combined. So you would get a one you would get a one single cluster. So this is a dendrogram. Now you guys can let me know if there is any confusion in this question. Let me know guys in chat section if there is any confusion. So I hope this question is clear to you that how to solve based on single linkage. Let me know. Okay, so if there is no confusion, let's move to next question. So yeah, next question I have is using average linkage clustering, agglomerative clustering, average linkage. Just try to solve it and let me tell you what is the distance formula between single linkage agglomerative clustering. So D of AB, A and B are two clusters and it would be summation dxy, x belongs to A, comma y belongs to B, equals to 1 upon cardinality of A into cardinality of B. That means number of points in cluster A, number of points in cluster B. So this is a distance between two clusters in average linkage. Now try to do the same thing, guys. Just tell me what would be the answer here. Just try to draw dendrogram by yourself. Let me know, guys, what dendrogram you would get. So first of all, you would take each of the point as single clusters. That means first set of clusters you would have A, B, and then C, and then D, and then E. Right? And now you can see that if you would look at the minimum distance. So minimum distance I have here is this one and this one. Right? So distance with A and B is 1 and distance with C and D is 1. So I can combine them together. Right? So I can get second set of clusters as A comma B. And I can have here C comma D and E. Right? So I get 3 clusters. Now, again, I have to find out a distance matrix to combine 2 clusters. So how do you find out the distance? I'll do the same thing. Let's find out the distance. So I'll have a points here, A comma B, C comma D, E. And then I have a point A comma B, C comma D, and E. Distance of A comma B with A comma B is 0, right? Prashant, you can, let's suppose they are asking for you 4 clusters. So then you can combine either AB or CD. It's up to you. But if they are asking you 1 cluster, so 3 clusters. So you can combine A and B, AB with C and CD simultaneously. Right? And you can draw the bars at equal distance. So now you need to find out distance of AB with CD. So what it would become? Distance of AB, A comma B cluster with C comma D. And what would be this distance? So number of elements in first cluster, number of points 2, and number of points in second cluster, that is also 2, right? And you have to take a summation. So summation of, that means you have to find out, I can write down like distance of A comma C plus distance of A comma D plus distance of B comma C plus distance of B comma D, right? That would be your average linkage, right? So that would be distance. So 1 by 4. Distance with A with C is 2. Distance of A with D is again 2. Distance of B with C is 2. And distance of B with D is 4. If you would add, it would become 10 by 4. That is 5 by 2. And you can write down this distance is 2.5. So I can write down this distance is 2.5. Now, can you guys tell me the distance of the cluster AB with E? Can you guys tell me this distance AB with E? Distance of AB with E. Now, if I need to find out the distance of cluster AB with the cluster E, it would become 1 by 2 into 1, because one cluster has, first cluster has 2 elements and second cluster has 1 element. And then I'll add distance of A comma E plus distance of B comma E. Right? It would become 1 by 2. Distance of A with E is 3 and distance of B with E is also 3. So you would get this distance 3. We'll get this 3. So it would become 2.530. Distance of CD with E. Guys, tell me what would be the, right, Prashant. Guys, tell me what is the distance bit of CD with E point. Just tell me what is the distance. I am writing here directly. I am solving here directly. I can say, because CD is 2 element, E has 1 element. Distance of C with E is 5 and distance of D with E is 3. So on solving, you would get the distance 4. So that means distance of C comma D with E is 4. You can just check and let me know if this thing is clear. So this is a distance metric. And if you would see the minimum distance is 2.5. Right. So minimum distance is 2.5. So that means what gets combined? You would combine A, B, C and D, right? These 4 points get combined and this is E. Now, next thing is that you would combine both the clusters to get one single cluster. So you would get the point A, comma, B, comma, C, comma, D, comma, E. If you get this hierarchy, now you can draw a dendrogram. So what is a dendrogram here? So I'll draw A, B, C, D, E. Right? AB gets combined, CD gets combined. Then AB, CD gets combined, and finally you would combine this with E. So this is a dendrogram you guys get. Now let me know if there is any confusion. Just let me know, guys. Just let me know, guys, on Zoom section, and let me introduce this session to you. That this is, in this session we are practicing question. We already have completed the syllabus, so we are practicing question, that how we are going to attempt questions based on machine learning. I hope this thing is clear. You can just ask me if there is any question at all. Let's move to next question. If this is clear. If there is any question, guys, just let me know. Okay, so this is a question they have asked in GATE DA 2024, right? Last year. So the table is given to you and single linkage clustering is performed on data points, right? Which one of the following is a correct representation of the clusters produced? You would get this set of clusters. Right? This is a clustering you would get. Now try to draw the dendrogram using this data set and using this distance metric, and let me know what would be the dendrogram. I'll show you the option first. Let's try to find out the clusters here. Just try to solve by yourself. Just take 1 minute time and try to solve by yourself. This is a GATE question. All students should be able to solve this question by themselves. What would you do? You would start, first you would see what is the minimum distance, and here I can see this is minimum, this is minimum. So first set of cluster is your each point individually x1, x2, x3, x4 and x5. All these 5 points individually form clusters. Now next step is x1, x2 gets combined. So you would combine x1 comma x2 and also x4, x5 get combined. x3 as it is, x4, comma, x5 gets combined, right? Now you have to form a distance metric. You have to find out a distance metric here. So let's find out that. So if I'll draw a distance metric, this is x1 comma x2, this is x3, and then x4 comma x5. Similarly, x1 comma x2, x3, x4 comma x5. Right, distance of x1 comma x2 with x1 comma x2 is 0. And guys, see, we are using single linkage. So don't get confused. If they are saying that you have to use single linkage, then you have to take a minimum distance, right? So now you need to find out distance of x1 comma x2 with x3. So if you would see, if I'll erase this, distance of x1, x2 with x3. So distance of x1 with x3 is 4 and x2 with x3 is 3. Out of these two, you have to take a minimum distance. So this distance would become 3. And similarly, you need to find out. I am writing it directly, guys. You can just expand it and understand that how we get the answer. I already solved one question using expansion. I'm not writing here. So distance of x1 with x4 is 3. Distance of x1 with x5 is x1 with x5 is 6. And distance of x2 with x4 is 5. x2 with x5 is 3. And you have to take a minimum distance out of this. So minimum distance is 3. So this distance gets 3. Right? Now, just check it once again that have we done everything correct? Because we are getting same distance here. x1, x4, x1, x5, right? x2, x4, x2, x5, right? We get the distance 3 and distance of x1, x2 with x3, right? 3. Okay, we get this distance 3. Now this is 3, this is 3, this is 0. Distance of x3 with x4, x5. Distance of x3 with x4, x5. So I'll find out distance of x3 with x4, that is 2. And x3 with x5, that is 5. So out of 2 and 5, we have a minimum distance, that is 2. So we get this distance metric. And I can see that this is minimum. If this is minimum, your third cluster would be that x3 and x4, x5 get combined. So you would get x1, x2. And another set of cluster is x3, x4, x5. Now you can finally combine both the cluster. So it would become x1, x2, x3, x4, x5. So that means this is a hierarchy you would get in your dendrogram. Right? Now it is now the only thing remain to draw a dendrogram. So guys, using this set of hierarchy, can you draw a dendrogram here and see which of the option is true? Can you guys tell me which of the option is true? Guys on Zoom section as well, if there is any confusion, you can just let me know. So I can see here that x1, x2 get combined and x4, x4, 5 gets combined at the same time. So either A or B can be true. Obviously C cannot be true and D cannot be true because here they combine x3, x4 first. Now after combining x1, x2, x4, x5, they have combined x3 with x4, x5. So that means option A is true because here they have combined x1, x2 with x3. Right? So here option A is correct. So I hope this question is clear. Let me know, guys. This is a GATE DA question, so that's why I'm putting emphasis on this question. So you should know all the linkage clustering. You should know all the formula so that you can solve questions. Should we move forward? Okay, let's move forward to next question. Okay, so now the question here is based on principal component analysis. So I assume that all of you know what is principal component analysis. We'll find out the maximum variance in our data set. right? So you can see that. Let's suppose this data set is given something like that. So I'll find out that particular direction in which we have maximum variance. So that means in this direction, I have maximum variance, and I'll project all the points on this line so that I can have my two-dimensional data into one-dimensional. Like this is my first principal component. When I project these points on this line, and if I'll take an orthogonal direction, that means the direction which is 90 degree to this first principal component, that is my second principal component, right? Okay, PCA lecture I haven't taken, so let me do one thing. Next week, this week I'm busy. So next week, let's do one thing. We haven't taken one lecture on dimensionality reduction on YouTube, so I'll try so that I can schedule one session for dimensionality reduction. Right? I'll make sure that it would be uploaded. I'll take the lecture in the next week on YouTube. Okay. Yeah. So this is my maximum variance I am having here. Maximum variance. Right? So that means we are capturing maximum variance in this. Okay, the most popular used dimensionality reduction algorithm is the principal component analysis. Which of the following is true about PCA? PCA is an unsupervised method of optimization, and that is true. It is an unsupervised learning because we do not consider the output. We just take all the features, and based on that, we'll reduce the dimension. If it is 5-dimensional, then I'll capture the dimension in which we have maximum variance, and that I call as principal component 1. And then I'll take another. Let's suppose you have a 5-dimensional data set and you have to convert it into 3-dimensional. So how would you convert? First, you would capture the direction in which you have maximum variance, and that is your principal component 1. Using that, you would find out your first feature. Now, for the second feature, what would I take? I'll take orthogonal direction, but because you already have 5-dimensional data, so that means this has 4 directions in which you can get orthogonality because it is 5 dimensions, right? So you would again, for principal component 2, you would take that it should be. Now for principal component 2, you have 2 conditions. First condition is that it should be orthogonal to principal component 1, and also it would be capturing maximum variance. You would, because you have 4 directions, then you would, out of 4 direction, you would take that particular direction in which you have maximum variance, right? It searches for the data direction that have largest variance. That is true. Maximum number of principal component less than equals to number of features. Obviously, na, what principal component analysis is doing? It is reducing your dimensionality, number of features. So obviously, maximum principal components we can have less than number of features. All principal components are orthogonal to each other. So this is also true. So here all options are correct. Now let me know, guys, if there is any confusion in this question. Just let me know. Let me know, guys, in chat section if there is any confusion. Let's move forward to next question. Yeah. What will happen when eigenvalues are roughly equal? So basically, guys, you for PCA, for principal component analysis, we first find out eigenvalue, and based on that, we find out eigenvectors, right? And these eigenvectors help us to find out. These eigenvectors are our principal components, and based on that, we are going to find out our new features. So if eigenvalues are roughly equal, let's suppose you have 4-dimensional data set and you have find out 4 eigenvalues. If all these 4 eigenvalues is equals to A, right? So that means you only get one eigenvector, right? You can have one eigenvector or more than one eigenvector also you can get, but because of this eigenvalue, there are chances that you would get one eigenvector. And in this case, you cannot have 3-dimensional or 2-dimensional 3-dimensional data set. You cannot reduce it to 3-dimension if you get only one eigenvector, right? So that means in this case, PCA will perform badly. Right, so here option B is true. Now, next question is, what happens when you get features in lower dimension using PCA? what would happen, guys? The features will still have interpretability. So let's suppose you are predicting price of a house. You have number of features, like let's say room size and number of rooms, size of a house, all those things. So these features are interpretable, that this is basically given to you number of rooms. Next feature is given to size of a house. Next feature is number of washrooms in a house. All these things given to you. But when you reduce using principal component analysis, so you do not know what new feature is like you are getting. Is it number of houses into, like, what is the interpretation of that particular feature? You do not know in principal component analysis. So what would you do? You say that when you reduce your features using principal component analysis, you lose interpretation, right? The features will lose interpretability. Next thing is, the feature must carry all the information present in the data. No, that is not true, right? When we reduce using dimensionality reduction by any method, it is PCA or LDA, any method, interpretability, I told you with an example, right? I hope now it is clear. Yeah, where were we? We were discussing that it must carry all the information. So when we reduce a data set using any dimensionality reduction method, we try to make that we do not lose much of the information, but there is always a lose of information, right? Because you are just moving to 5-dimensional to 3-dimensional, or 3-dimensional to 2-dimensional. You are just moving in lower dimension, so there would be a loss of data, but you would take that technique in which you have minimum data loss, right? Minimum loss of data. The feature may not carry all the information present in the data. So option 4 is correct. So here second and 4 are correct. Interpretability is that what this feature means us here, right? So when we are saying that, let's suppose we are predicting price of a house, right? I have taken the example at the start. When I have n number of features, I can say, when I have n number of features, I can say that this particular feature is telling me this, second feature is telling me this, third feature is telling me this. But when I have so I have interpretations, right? That this feature is meaning is giving this meaning to us, right? Next feature is this meaning. But when we reduce using principal component analysis, now we get new features, and these features are nothing but a set of vectors, right? So now you do not know what these features mean, right? What do you mean by these features? This is number of houses, number of, what this feature mean? It is basically combination of all the five features you have already have, and it is reduced in reduced format. Let me know if this thing is clear. Let me know, guys. Okay, let's solve next question. Let's solve next question. Okay, so imagine you are given the scatter plot between height and weight. Select the angle which will capture maximum variability along a single axis. Can you tell me in which direction you would have a maximum variability along a single axis? Can you guys tell me? So you can see that where we are having maximum variance, we are having maximum variance in this direction, and that is 45 degree, right? So here option B is correct. This is simple question, right? Simple question. Okay, so is there any change in that combination or not? Just let me know. Okay, so we have another question based on principal component analysis. It says that you need to initialize parameters in PCA. You do not need to initialize parameters in PCA. PCA can be trapped in local minima problem. PCA cannot be trapped in local minima problem. So guys, see, PCA is a non-parametric algorithm, right? You are not using any parameters here. You do not have any parameters to train. What you have number of features, and you are finding out max direction in which you have maximum variance. So you are not doing iteration so that you can find out the best value of the parameter. You are not doing that. So that's why you can see that you do not need to initialize parameters in PCA. And also one more thing, PCA can't be trapped in local minima because we are not finding out maxima and minima in this problem, right? Where we have done that when we have testing our data, right? And capturing that how much loss value we have, and we are going to minimize that loss. But here we just have to reduce the dimensionality, right? So here second and fourth options are two. Let me know, guys, if there is any confusion. Just tell me, guys, if there is any confusion. Okay, there is one question. What is the question? In logistic regression is a highly interpretable. Can you explain how? So what logistic regression does? It's basically does classification, right? Okay. Just tell me, guys. Let me also check. I have confusion in this. Do you think that logistic regression has maximum interpretation? That is true, right? So basically, what logistic regression does? Let's see. Right, Prashant. So basically, what logistic regression does, you would write down, you would find out a model that is, uh, z is equals to w1 x1 plus w2 x2 plus b, right? This kind of a model. Let's say we have two input features, right? First of all, I know that if w1 is positive, that means we are giving positive importance to this feature x1, and if w2 is important, we are giving this much importance to x2. And then I'll put it into 1 upon 1 plus e to the power minus z, right? So as z increases, as the value of z increases, what would happen? If z increases, minus z decreases, then 1 plus e to the power minus z decreases, and 1 upon 1 plus e to the power minus z increases, right? This is mathematics. So if this value z, w1 x1 plus w2 x2 plus b is increasing, that means your sigma z value is increasing. And this value is always between 0 and 1, right? It would always lies between 0 and 1. Sigma z less than 1. So by taking the value of w1, w2 large, what would happen? If I make a small change, if I'll increase small value of w1 and increase small value of w2, then there is an increase in sigma z exponentially, right? So probability would go to closer to 1, and also it is giving me probability. That what is the probability? It would not give me that it is giving you 0 or 1, right? It is not telling me that your class is 0 or your class is 1. I'm talking about binary classification, right? It is telling me that what is the probability that you are having this class 1. What is the probability you are having in class 0? That is given by 1 minus sigma z, right? So that's why we say that there is much interpretation as compared to any another model. Now you would say that, ma'am, naive Bayes algorithm also gives us probability, right? This would be the question. But in naive Bayes algorithm, you would see that we have what we have assumed, that all the features are independent and conditional probability are independent on classes, right? So we have taken so much of the things so that we have less interpretations here, but here we have feature importance. It is given in this model, right? Because it gives us probability. And similarly, you can say that your in your multi-class classification as well. Now let me know if there is anyone else has confusion. So basically I am saying that as the feature importance, like W1 जो है वो help करता है increasing the importance of the feature x1, right? अगर मेरे पास x1 ज्यादा इंपॉर्टेंट है तो W1 की वैल्यू ज्यादा पॉजिटिव होगी. अगर z बढ़ रहा है मेरा, वो कैसे बढ़ेगा? जब W1 W2 और B इंक्रीज होंगे तो क्या होता है? माइनस z डिक्रीज होगा, 1 प्लस e टू दी पावर माइनस z भी डिक्रीज होगा, बट 1/1 प्लस e टू दी पावर माइनस z इंक्रीज होगा. सो दैट मीन्स प्रोबेबिलिटी 1 की तरफ ज्यादा चली जाएगी, राइट? सिग्मा z बड़ा हो जाएगा. सो हेयर अब हमें यहाँ पे क्या मिल रहा है? यहाँ पे हमें प्रोबेबिलिटीज मिल रही हैं, राइट? और ये प्रोबेबिलिटीज देखो सब कुछ इंटरप्रिटेबल है इस पॉइंट पे. कोई कॉम्प्लेक्स इंटरेक्शन नहीं हो रही है, कुछ नहीं हो रहा है, हमको सब समझ में आ रहा है. सो दैट्स व्हाई वी से दैट लॉजिस्टिक रिग्रेशन इज मोर इंटरप्रेटेबल. बिकॉज अब यहाँ पे भी देखो एन में भी ये मेरे को प्रोबेबिलिटी दे रहा है कि 1 क्लास के होने की कितनी प्रोबेबिलिटी है, 0 क्लास के होने की कितनी प्रोबेबिलिटी है. Let me know guys if there is anyone else has confusion. Okay, there is one question, that is, does logistic function to equal to inward log it, ma'am? So basically guys, you can say that this function is inward log it, or this function is you can say that this function is what? Sigmoid function. You can say this function anything, right? So there are different names, either it is inward log it or sigmoid. Let me know if there is anyone else has confusion in this. Okay, so shall we solve more question? Let's move forward to solve next question. Which of the following offset do we consider in PCA? So in principal component analysis, which offset we'll consider? Vertical offset, perpendicular offset, both. Let me know guys, which offset we consider in principal component analysis. So you can see that in this vertical offset, what would happen? You would find out the distance between y and this y dash. This offset you have used in linear regression for cost function, right? You have find out that this is your y, exact y, this is your predicted, okay. Yes. So this is your predicted y cap, and this is your y. So this vertical offset you used in cost function of linear regression, loss function of linear regression. But this perpendicular offset, what would you do? You would take the direction in which you have maximum variance and you project all the points perpendicularly. right? So that's why we use perpendicular offset in principal component analysis, right, Prashant? We are going to use perpendicular offset. Let me know, guys, if there is any question in this. Okay, let's try to solve next question. So guys, this is a question based on linear discriminant analysis. So let me give you an overview that what is linear discriminant analysis. So when we have maximum variance, right? If I am going to capture maximum variance, let's suppose this is maximum variance and this direction I have taken is your principal component analysis. But in case of classification, what would happen? In case of classification, let's suppose you have this kind of a data set, right? And you have circles here, right? So let's suppose you thought that let's ma'am work using PCA, right? You would say that you would find out the direction in which you have maximum variance. Obviously, this is maximum variance direction. What would you do? You would project all these points on this line, but you can see that by projecting all these points on this line, you are not able to classify. You are not able to classify. See, you have cross and dot on a single line, and that is like basically like making problem to making problem in classification. We have to reduce the dimension, but we have to make sure at the same time that our classification works properly. Here I cannot take maximum variance. Basically I have to find out that particular classification here, that particular classification. Which classification you would find out? I'll take this direction. By this direction, you can see that if you would project all these points here, all these points here, right? Now you can see that you can simply you would get all the points cross here, dots here. Now you can easily classify, right? So you can say that let's suppose this point is 5, all the points less than 5 classified as cross, all the points less greater than 5 classified as dot. In linear, Prashant is asking, in linear regression is vertical and PCA is perpendicular? No, we cannot say that. We cannot say that in linear regression vertical and PCA are perpendicular. That is not true here. Basically you are saying that vertical offset, either I'm going to use first, let's suppose I'm applying PCA. Once I get the data set, then I can apply linear regression. Vertical offset and perpendicular offset, both are different things, right? So I have, how I'm going to decide that I am getting the best direction? So that means I have to make sure that within class I have minimum variance, and out of the class I have maximum variance, right? So that means within class you have minimum variance. You can see that you have to take the direction in which you have minimum variance, and outside of the class you have maximum variance. You have to take that particular direction. So LDA works on that principle. Now let's get back to the question. Which of the following is true about LDA? So that means between any two classes, we have to take maximum variance, and within class variance, we have to minimize. So good class separation is that when you have between class variance is maximum and within class variance is minimum. That is your goods class separation. LDA aims to maximize the distance between classes and minimize within class distance, right? This is true because I have to maximize the distance between classes and minimize within class distance. That is true. LDA aims to minimize both distances. That is false. LDA aims to minimize the distance between classes. But if I have to minimize the distance between classes, I'll take this direction. All the points gets project to this line. Now we do not have any separation, right? So that is not true. LDA aims to minimize the distance between classes, and right, that is not true. LDA aims to maximize both distance. If we will maximize both distance, that is also not true. Now let me know, guys, if this thing is clear, that LDA aims to maximize the distance between classes and minimize within class distance. Let me know if there is any confusion. Let me know, guys, if there is any confusion at all. Okay, let's solve more questions then. Which of the following comparisons are true about PCA and LDA? Both LDA and PCA are linear transformation techniques. LDA uses supervised learning where PCA uses unsupervised learning. PCA maximizes the variance of the data, whereas LDA maximizes the separation between different classes, or none of these. So you can tell me directly that here option first, second, third are true, right? All these three statements are true about these algorithm. And this simple question, basic idea about this algorithm, about these algorithm. You guys can let me know if there is any confusion at all till now. Okay, let's move forward to next question. In LDA, the idea is to find the line that separates both the classes in the given image. Which of the following is a good projection, guys? In LDA, in case of LD1, we have given the diagram. LD1 is a good projection, or LD2, in which direction I'll project the points. And again, in LDA as well, we have to project the points perpendicularly. Let me know. Obviously, in which direction I'll do the classification, or I'll use LDA in this direction. LD1 is my correct answer. So here option A is correct. Right? This is a simple question. Obviously, na. Otherwise, you would take this direction, all those points gets in this line, on this line. Obviously, you would not get a good separation here. So this is also option A is true. So guys, this is a question based on support vector machine. Suppose you are using a linear SVM classifier with two-class classification problem. Consider the following data in which points circled red represent support vectors. Will the decision boundary change if any of the red points are removed? Yes or no? Let me know, guys. So what support vector machine does? It basically does classification. And on what basis it would work? You would have a random classification, and then you would find out the distance between the closest point of that classification from both the classes. You would draw two margins, you would get a hyperplane, you would find out the maximum direction, and then you have to minimize that particular distance 2 by modulus of W. You have to do that in SVM. Now, will the decision boundary change if any of the red points are removed? So let's suppose you have taken a classification here. So if you would see that you have a minimum distance of this class is this and this, right? So you would draw two hyperplanes here. This is your H1, this is your H2. You have to maximize this distance. Let's suppose this point gets removed here. This point gets removed. Then your distance would become this, right? And then it has to change, right? It has to change. So it would become change. Right? If plus points gets removed, then obviously there is a change. But if minus point gets removed, there is no change. So obviously, if any of the red point change, it can change. Yes. Right? So this is clear. Now let's see next question. Okay. Now the question here is, this is next question. If you remove the non-circled red points from the data, this decision boundary will change. No, decision boundary will not change if you would remove any of the non-circled data points, because the support vectors only emphasize to make a change in support your decision boundary, right? Now let me know if this thing is clear. This is a question. Which options are true for SVM? The distance of the vectors from the margin is called hyperplane. No, distance is not called hyperplane. Thus, the plane which passes through support vectors and parallel to your decision boundary, that is your hyperplane. Or hyperplane, you can say that decision boundary. The loss function that helps minimize the margin is called hinge loss. the loss function that helps minimize the margin is called hinge loss. Yeah, that is true. SVM can solve the linearly separable data points. SVM can solve the data points that are not linearly separable. So guys, obviously SVM can solve the points which are linearly separable. But also it can solve the points which are non-linearly separable by using a kernel, right? We add kernel in our SVM and we'll able to solve the points which are not linearly separable, guys. But before this, you have to check that about hinge loss. Just check this about. I'm not sure about this. Okay, so basically we have to maximize the margin. Maximize the margin. So that's why this option B is not true, because we have to maximize the margin. That means the distance between decision boundary and support vectors, I have to maximize that. So that's why option B is not true, because it is saying that you have to minimize the margin, right? So C and D are correct option. Okay, so guys, this question just try to solve by yourself. You have to find out maximum margin hyperplane. So you have given three plane H1, H2, H3. Can you let me know that which hyperplane gives you maximum margin? So just try to solve by yourself. We'll continue the session further in next classes, right? So I think we have to take one more session because we are left with some of the SVM question and some of the neural network question. I think I'll take one more session based on the questions practice, and then we are going to work on different subjects. You can just let me know, guys, if there is any question or any confusion. And guys, before ending the session, please like the session and share it with more students so that it can reach to more students. Okay, so yeah, that's all from my side, guys. Thank you for joining.